Welcome back to our channel PrashY. Learning is fun. In this module, let us have some fun with magnets. You all know that a magnet has two poles, namely North Pole and South Pole. So the dotted end indicates the North Pole. So if I place the two North poles together, then we can see that they repel each other. So two North poles together means they are like poles. So when like poles are brought close together, they repel each other. Similarly, when I bring South Pole and South Pole, they repel each other. This property is called as repulsive property. If I bring a North Pole and a South Pole together, they attract each other. Means when a North Pole and a South Pole are brought close together, they are opposite poles. Opposite poles means unlike poles. So unlike poles will attract each other. So this property we call it as attractive property. In this we say that like poles repel each other and unlike poles attract each other. This attraction and repulsion is due to the magnetic force. A magnet can attract or repel another magnet without contact. So magnetic force is called field force. Let us define field force. The force which acts between two bodies when the bodies are not directly touching each other is called as field force or force at a distance. It is understood that every magnet has a field around it. Okay, let us try to visualize the magnetic field. So let us do a small activity to visualize the magnetic field. Take a bar magnet and place it on a table. Now place a thick white paper on it. On the paper, sprinkle fine powder of iron filings. So observe the pattern here. All the iron filings set themselves in a pattern. So this is because of the influence of the magnet. All the iron filings are getting influenced by the magnet. So these field lines are created because of the bar magnet. This pattern represents the magnetic field. What is a magnetic field? The space around the magnet where its influence can be detected is called as magnetic field. So the magnetic field surrounds a magnet, electric field surrounds an electric charges, and gravitational field surrounds the masses. Magnetic force, electric force and gravitational force are field forces. So these three has field around them. If we observe the spacing between the lines at some places, the field is crowded and it is maximum near the poles. So in some places the field lines are spread apart. By this we can say that field is strong when the lines are crowded and field is weak when the lines are spread apart. Thus the field obtained by a bar magnet is non-uniform as its strength and direction changes from point to point. And the field is said to be uniform if both strength and direction are constant throughout the field. Let us perform another activity to know whether the magnetic field has direction. Take a white paper and place it on a table. Now place a bar magnet in the middle of the sheet. Now place a magnetic compass near the magnet. So the compass settles at a certain direction. So turn the compass till the North Pole and the pointer indicates the North Pole. Now put the dots near the North Pole and the South Pole. Remove the compass, join these two lines using a pencil. Draw an arrow from South Pole of the needle to the North Pole of the needle. Now place the compass at another distance and in the place. So now this is the North Pole and this is your South Pole. So join these two. So this is your direction. Now place compass at another point here. It is showing deflection. So this is our south pole and this is north pole. Now when I place a compass here, this is the north pole and this is the south pole. So on repeating, we are finding that the compass needle is showing different directions. So here the needle of the compass is affected by the presence of the bar magnet. So without any physical contact, this magnetic compass is affected by the presence of this bar magnet. So from this activity, we got an idea that magnetic field has direction and it is varies from one point to another point. So let us find out the direction of the magnetic field due to a bar magnet by doing another activity. Place a white sheet of paper on a horizontal table. Place a compass in the middle of it. Now turn the compass showing north-south direction. So put two dots on either side of the compass needle and remove the compass and draw the line connecting the dots, which shows north and south of the earth. This is north pole. This is south. Now place a bar magnet on the straight line drawn in such a way that north pole points towards the geographic north. So north pole is pointing towards geographic north. Now place the compass at the north pole of the bar magnet. So now turn the compass such that north pole shows the pointer. So I am placing dots on the north pole and the south pole. So on removing, this is the direction of the north pole. Now I will place the magnetic compass exactly at this point. So now I have to turn the compass such that pointer shows north-south direction. Now again changing the direction. So I am placing the dots starting from north pole to the south pole. So these are the arrow marks. So the field is moving from north pole to south pole. So this is the direction of the magnetic field. Similarly, I want to start from here. Downward also I will check it out. So north pole. So I am getting south pole here. South. South. North and south. North and south. So the magnetic field lines are starting from north pole and ending at south pole. So the magnetic field. So repeat the same process starting from the north pole to the south pole, even to, slowly changing the direction. So on repeating the process, we get different curved lines. Technically, these curved lines are called magnetic field lines. These field lines are imaginary lines. These lines help us to understand the nature of the field. These field lines are closed loops. They start from north pole and ends at south pole. And inside the bar magnet, they move from south pole to north pole. So we say that the field lines are closed loops. That's all from this video. Hope you enjoyed the video.